So what happens when a massive, continent-wide climate crisis slams head-on into a technological revolution? Well, that's what we're going to unpack today. Because right in the middle of this collision is something we all depend on, Europe's power grid. And honestly, it's starting to buckle under the pressure.
Let's just kick things off with a number that is, well, it's just shocking. 70 billion euros. And get this, that's not the total cost of all the climate damage. No, that's the price tag every single year from now until 2050, just to protect our homes, our roads, and our power, according to a brand new study for the European Commission.
Okay, so a number that big, it feels almost impossible to wrap your head around, right? So the big questions are, why is that price tag so incredibly high? And what on earth can we do to manage it? Let's break down what's really driving this crisis, and then we'll look at a really new, kind of groundbreaking approach that could help us fight back.
And look, the urgency here couldn't be clearer. This isn't some distant problem for our grandkids. The European Climate Risk Assessment is basically screaming a warning. If we don't take decisive action right now, we're on a direct path to catastrophe. This goes way beyond money. We're talking about survival.
So here's the root of the problem. It's actually pretty simple. According to the very latest climate reports, Europe is warming up at twice the global average. Let me say that again, twice the global average. No other continent is heating up this fast, period.
And this chart, this really puts it into perspective. That blue line, that's the warming that's already happened. The colored bands, well, that's where we're headed. And what's really stark is that even in the best case, most optimistic scenario, that trend is still shooting sharply upwards. The high emissions path, I mean, you can see for yourself. It's just catastrophic. And you know, this isn't just theory. We are living these consequences right now. I'm talking about the devastating floods in Germany and Belgium, the ones that cost billions, or the droughts and wildfires that are just crippling Southern Europe. These extreme events, they're becoming the new and very unsettling normal.
And the human cost, it's just staggering. Just think about this. In the summer of 2022 alone, just that one summer, an estimated 70,000 people in Europe died prematurely because of the heat. This is a massive public health crisis, and it's happening right now.
Okay, so you take all of this extreme heat, all this water, all this wind, and it puts an absolutely unprecedented strain on the one thing that holds our modern society together, the power grid. You know, the system that keeps the lights on, keeps hospitals running, keeps the whole economy moving. And it turns out it's incredibly vulnerable.
And the grid is facing this kind of twin threat. On one hand, you've got the obvious physical damage from extreme weather, ice pulling down power lines till they snap. But on the other hand, there's a more subtle problem. As we switch to renewables like wind and solar, the grid itself actually becomes less stable. Think of old power plants with their giant spinning turbines. They have this physical momentum, it's called inertia, that acts like a shock absorber for the grid. Wind and solar, they don't have that. So the whole system gets a lot more fragile, a lot more jumpy.
And that fragility can lead to every grid operator's absolute worst nightmare, something called a cascading failure. It's literally a domino effect. One power line goes down, which forces all its electricity onto another line, which then gets overloaded and goes down, and so on, until the whole system just collapses into a massive blackout.
And hey, this isn't just a what-if scenario. This stuff really happens. Back in 2019, a single line going out in the UK knocked out power for over 1 million people. And remember what happened in Texas in 2021? An ice storm triggered a total grid collapse that left millions of people in the freezing dark for days. It just goes to show how fragile even modern grids can be.
Okay, so the challenge is massive. It's overwhelming. So how in the world do we fight back? Well, a lot of researchers are starting to believe the answer lies with artificial intelligence. The idea is to use AI to build a grid that's not just stronger, but a whole lot smarter.
And the way AI can help is basically a 1-2 punch. First, it gives us the power to predict, with amazing accuracy, exactly where and when a weather threat is going to hit. And second, it gives us the power to react, in milliseconds, to stabilize the grid and stop those cascading failures before they can even start.
So you can really think of it in two ways. On one side, you have an AI that's like a lookout, peering into the future to warn us about incoming threats. On the other, you have an AI that's like a high-speed pilot, reacting in the present moment to keep the whole system perfectly balanced. Let's dig into the lookout first.
Okay, so first up is something called a weather foundation model. And the best way to think about this is like a personal weather psychic for every single power line. It's this huge AI that's been trained on just enormous amounts of global climate data, but then it's fine-tuned with super specific local data from the actual utility company on the ground.
And the results? They're pretty incredible. When you put it up against the best traditional weather models out there, this AI is 35% better at predicting rain, which is huge for floods, and about 15% better for wind and temperature. I mean, these aren't tiny little improvements. For the people running the grid, these are absolute game changers.
But here's the really crucial part. This AI can predict threats that before now were almost impossible to forecast. Things like rime ice. It's the specific kind of ice that just cakes onto power lines until they collapse under the weight. The AI's precision score is 0.72, which basically means it's right way more often than it's wrong. And that gives repair crews hours of advance warning they never had before.
Okay, so that's the lookout. Now let's talk about the pilot. This second AI tool is called an Adaptive Admittance Controller, and it's basically an incredibly fast air traffic controller but for electricity. It's constantly watching the flow of power, and if a line suddenly goes down, it reroutes everything in milliseconds to prevent jams and crashes across the system.
And the impact here is just as big. They ran simulations using a model of the actual UK power grid, and this AI cut down those dangerous frequency wobbles, the things that lead to blackouts, by an average of 53%. That is huge. This kind of AI stabilization really could have a global impact. We're talking about potentially redefining what a resilient grid looks like for everyone.
So when you put all this together, what does it mean for the big picture? Well, it means we can finally start shifting from just reacting to disasters after they happen to actually proactively building a future that's much more resilient from the ground up.
Now, let's be clear. AI isn't some magic wand that's going to solve climate change overnight, but it is a powerful new set of tools in our toolbox. It allows us to be smarter, to be faster, and to be way more precise in a fight that is, let's face it, pretty daunting in its scale and its cost.
And ultimately, as the head of the World Meteorological Organization puts it, technology by itself just isn't enough. The challenge is just too big. It's going to take coordinated, fast action from everyone at every level of society and across every border.
Which really leaves us with one final critical question. We are in a race. It's a race between a climate that is changing faster than ever and our own ingenuity. The technology to fight back is here. It's arriving now. But is it arriving fast enough? Honestly, the answer to that question is going to define our future.